Wait, I'll try presenting my screen. Why are there two Vidishas? Oh, one is. Wait, are Ashley and Vidisha sitting in the same room as you?
No,
Nice.
they're not here.
Tell if you can see.
I can see.
Okay. The quality is fine, no? Like the
Yeah, it's good.
quality. No, as in like the video quality.
Yeah, that one, it's good.
Yeah. One second. Yeah, I can hear you. I'm just trying to mute myself. Yeah, go on.
It's over, Arya, it's over. No, it's not completely over. They're doing the thank you thing. It's just starting now. I want a light. It'd be better if I had a light. But look at that.
I think those guys are having problems joining the meet.
It's like a stand or something. I'll keep my torch on.
Wait, what happened?
What happened?
I don't. Wait, what did he say? Why do you have to use your torch?
I was talking to her.
Oh, okay.
One of it click here.
Join. Hello guys, am I audible?
Yeah, hi. Yeah, you're audible. Yeah.
Yeah, hi. So thank you for joining. We'll be starting shortly once all our experts join the meet.
Jonathan is here. Is John? Hi, Jonathan. Am I pronouncing your name right?
Hello. Yeah, you are.
Oh, that's good.
Nice to see you all.
1 sec. Yeah, nice to see you too.
Thank you for joining.
So, I was 1 second. I'll just bring up. Hi, Shivramakrishna is also here. Hello, welcome. Thanks for coming. I hope I'm pronouncing your name right. Shivramakrishna is fine, or should I?
Yeah, that's fine. You can probably just call me Shiva. It's a mouthful.
Yeah,
Otherwise.
cool. Yeah, cool. Right, so I called you guys a bit early because I wanted to ask you whether, so we've sent you the questions before. So some of the questions are pretty technical, and I wanted to know, in case you guys wanted to have access to some iGEM accounts, if you want to show some of the questions. Like one of the questions was about the CSS styles and like those messing with the defaults of what iGEM gives us. Would you guys want to have access to one of our accounts to, in case you want to show something? Is that what you're planning, or like would you guys just prefer to answer it over voice? Is that fine for you? Do you guys have anything in mind? Otherwise, we'll just do it normally. In case you want to have access, then yeah, we should plan it earlier. That's all.
So I still have an iGEM login, so it should be fine for me.
Yeah, cool.
I think it's fine for me. I don't think I will need to share something.
Yeah, sure, cool. And I just wanted to mention that all the questions, so there are 12 questions that I sent you. All the questions you guys can answer any of them. Like multiple people can answer any of them, so that should be fine. I think that's it for now. We'll just wait for like 5 more minutes and we'll start.
Just a quick mic check. Can you hear me okay?
Yeah, we can hear you okay. Thanks for coming.
Okay, super. Yeah, glad to be here.
Okay, fine. How do I pronounce your name? Is it Baldur or Baldur? Am I pronouncing your name right? Baldur, okay, cool.
Yeah, I mean, you actually have great pronunciation.
I've seen you. Thank you.
Most people here in Denmark would call me Baldua.
Oh, okay. Nice to know.
Am I audible?
Kind of, but very low.
Hello, am I audible?
You are, but still pretty low. Your voice is still very low.
Okay, I'll just try to speak in a louder voice. Is this better?
It is better now, yeah.
So, hello everyone, I hope you all are doing well. Welcome to the day 2 of our Cyanobacteria Symposium. I'm Isha from Team IISER-Pune-India and I'll be your host for this. So even though the Cyanobacteria Symposium was organized to bring together teams working on cyanobacteria, events for today were planned for all iGEM teams to guide them about some essential aspects of iGEM and to celebrate their efforts till now. Today's event is packed with interesting talks, workshops, games, and more. So without taking any more time, I'd now like to hand over the platform to Jason and Namasi from Team IISER-Pune-India to introduce our panel of experts for our first event for today, the wiki workshop. Jason and Namasi, please take.
Yeah.
Hi, thank you. Am I audible? Is my mic audible?
Yeah, it is. Yeah.
Securely audible.
Right. So, hi everyone, and welcome to this wiki workshop organized by iGEM IISER-Pune. The wiki is the very face of every project and holds a pretty important role in displaying a team's work in the competition itself and to the rest of the world. At the same time, most participants don't have prior experience in making wikis or in building websites. So in this 1-hour workshop, we will try to bridge this gap and with the help of these 3 amazing experts, Baldur, Shivaram and Jonathan. the speakers have been very involved in the iGEM wiki process before, and so we felt they would be perfect for this workshop. This workshop is divided into two parts. The first 45 minutes have been kept for a list of questions that we already prepared for a Q&A session, and the second part is for a discussion session.
We've prepared a list of questions that cover most of the wiki process, and each of these questions could be answered by any of the speakers. We request that the teams put up any of their follow-up questions in the chat box so that we'll compile them and then they'll be answered at the end of the Q&A. If you have any immediate follow-ups that you feel should be asked at the moment, please raise your hand and you can unmute and talk. Once the Q&A session is over and the chat box follow-ups also have been gone through, we'll move on to the second part for about 15 minutes for a short discussion. This is meant for the teams in attendance to ask other questions that had not been addressed in the Q&A session and other more team-specific questions. If you can either ask them in the chat or raise your hand to ask your question over voice, that would work in the discussion. Try to keep your questions a bit general so that the other teams can also benefit from them and so that we don't have to take up too much time from the speakers. If you have any more questions which are specific, you should probably reach out to the speakers directly with their explicit permission over email or other media that they might be comfortable with.
We will be recording this meeting, and we're also trying to provide a transcript of the meeting as soon as possible. We'll also try to make notes of this meeting and send them out later. If the speakers would like to give a short introduction about themselves and what they're doing right now, they can go ahead and then we shall move on to the Q&A. Would anyone like to start, or should we just move on to the Q&A?
Hello, everyone.
Yeah.
I'm Baldur. I was part of the 2020 STU Denmark iGEM team. We won a few prizes, including Best Wiki. I have no HTML experience, so I can't answer your technical questions, but I hope I can help you with some other questions that you have.
Sure.
So, hi everyone, my name is Shiva and I was part of the 2019 Shastra iGEM team from India, and I was also involved in the wiki process for my team and other software related activities. I am now part of iGEM Creative Productions, where we do a lot of coding as well, and we're hopefully looking to change the process of submissions for the wiki.
Thanks.
And I am Jonathan, and I have been part of the Linköping iGEM team year 2017 and 19, and especially in the last time it went very well, so we won the Wiki prize, and I think that's why I'm here now. Right now I am working with software development at a company where we're working mainly with app development for healthcare.
Okay. Nice. That's great. So we'll move on to the Q&A session. So the first question we had for today was, what do you think is the best structured workflow for implementing the design of the wiki? So for example, let's say a team is starting to build a wiki. So for example, there's a basic example given here about starting with the home page or the landing page, then making the nav bar, then the main templates, and then the special templates for other pages. So what do you guys think would be a appropriate flow for such work? And what did you guys use, for example?
May I?
Yeah, sure.
I would say that this here flow that you have for an example is a path flow. You should think about it as a report. That's what you're doing, right? You're writing a report on a wiki. So you don't start with the home page. Your home page is your abstract.
Okay.
It should not take more than a minute to read your home page and understand your project. Like, it should not take me longer than a minute to read an abstract and understand what's going on. So you start with the meat, you know, whatever your meat is, if you know what I mean. And then you build the skeleton out from that, just like you're writing a report. And then you can assign that skeleton to different landing pages.
That makes sense. That makes sense. Thank you for your inputs. Do any of the other speakers have any inputs?
Yeah. Sorry.
Go ahead. Okay.
All right. Oops. I think we should just go alphabetically. So you go first.
Okay. Yeah. Hard with the delays here. So from the perspective of designing like the how to build up the web page, I think this actually is a good flow to start with the different pages you have and see like how do we want to design them, especially from the point of the iGEM wiki page where you already have kind of a given what pages you have to have. But from a content perspective, I agree exactly with Baldur to look at it, to write and see what content you have and then assign it. So yeah, and I think the content is the most important. So that is something I really want to try out. That it's not about making the best technical web page. It's about presenting your information the best way.
To add on to what my fellow speaker said, I think an interesting way to go about creating content would be Google Docs. But in this day and age, teams could try to make use of Markdown as an interesting way of keeping together rich content, and maybe teams could have all the content as separate Markdown files, and then make use of a Markdown parser in order to sort of get it converted to HTML.
Yeah, that's a new idea. That's nice. Would you guys have any inputs on a good timeline for the wiki implementation process? Because that's something I think many teams struggle with. Getting to the last minute wiki freeze and then trying to make changes. So, how much time should some team spend on laying out the most of the wiki's content and then designing it or something like that? Do you have any suggestions?
My start guideline is to start as early as possible. Like you are working on during the whole summer with all these experiments, and from the start try to write down what have you done, what are your results, and try to get into writing the content and capturing your images and graphs. And also, if you want to create your own web page, I think it's important to do that as early as possible. But otherwise, you could start to use the given web pages that you are handed out.
Yeah.
One practice that my team found useful early on was to sort of lay out a lot of CSS beforehand, so that we could sort of just remember the CSS classes that we would require for representing content in an easy way. So I would definitely encourage having 4 or 5 CSS templates that you create beforehand and upload to the iGEM servers, so that you can sort of just call those pages beforehand, before the freeze. That would be useful. So you wouldn't be really defining new classes and new styles later on.
One thing that we did is that we were a pretty large team compared to some other groups. So we had like a very specific people focused on the wiki, but we were always writing the wiki. So we had like a SharePoint server where the wiki was always being written, even though we didn't have anything on the wiki. If that makes sense.
Yeah.
And then we went through like PowerPoint, for example, and we came up and we looked at other wikis that we liked, and we looked at wikis that we didn't like. We picked things that we liked, and then we made mock-ups in PowerPoint. And then we did, like what she was saying, we made the templates from like what we liked in PowerPoint. And then we could start uploading the content.
That's a great idea. Yeah, nice. I think we're done with this question, so we move on to the next one. Okay, thanks.
Yeah. So how could we make these wikis more accessible and usable to wider audience. So alt text for images exist and adjustable font sizes exist, but what else can we incorporate into our wikis so that we're able to reach a bigger audience?
I'd like to take this first with an example. The team that won the grand prize last year, Vilnius, Lithuania, they actually have a very nice guide for graphic design as part of the wiki that makes text more accessible. So apart from alternative text and adjustable font sizes, one other thing that is of pretty good use and addresses more practical concerns is color accessibility. So for people who are colorblind, it makes sense to use colors that lie within their visual spectrum. So please check out Vilnius, Lithuania's 2020 iGEM wiki.
As a colorblind person, thank you very much. There's a lot of unusable charts out there. But from a different way of approaching this, I had like two philosophies in mind when we were making the wikis. The first is KISS, which I printed out and put all over our workshop. It's KISS. It's keep it simple, stupid. Everything you can do, just keep it simple. Don't make it complicated. There's a lot of wikis out there that try to be fancy and complicated, and I still don't know what their project was. And the second one that I kept in mind while I was making this is I want to show my mother this. I want my mom to be able to take a look at the wiki and understand what's going on. And one way we did to achieve that is we kept if you take a look at our wiki, we kept very simple pages, like landing pages. So this is our lab page. This is what we have achieved. And then you could expand on it. You could open more boxes for more information.
I think you two put out two very important different points. Kind of like two areas of accessibility. Both have it accessible. Every person needs to be able to get the content and to be able to understand the content. And I think that's very important to think in both areas. And I also like to add that you try to test different tools, test different kind of screens and browsers and mobile devices so it works in all these different kinds, because it will not by default. So you have to test to get it to work and test different text-to-speech tools, so it is able to use this web page if you are blind, or try to test different tools. And I think there are a lot of different tools that are available that you can find online and use to get the web page to be more accessible.
I think we're done with this question, so we'll go to the next one. Right, so about actually building the wiki. What tools? So we are using WikiSync. Have you three speakers heard of WikiSync? I mean, this is just one of the tools that Pitspilani Goa built last year for uploading to the website and making wikis easier to build. Not build, they have another thing for making it easier to build too. Are there any other resources or tools that you guys used or you would recommend that other teams should start using, which will make it easier for teams to build?
I'd actually say that WikiSync is an excellent addition to iGEM software. It really makes going from, say, VS Code to the bare bones editor within MediaWiki, it makes that process quite seamless. It makes the build process really seamless, which is an excellent way to go about it. On that note, you guys could probably try using CSS tools like Tailwind CSS, which again is a utility first framework that optimizes on build. And you could also try using another framework for dynamic JavaScript like Alpine.js. Alpine is sort of like React or Vue, except that it's much smaller and can actually fit within the size limits of the iGEM servers per team. I think it's like only a few kilobytes when minified. So that would be really useful to have dynamic content on your websites.
That's great. Do the other speakers have any comments? Or
all I have is that almost nobody, there was only one person in our whole team that knew HTML when we were doing our wiki. So we had our own workshop where he taught us, but we used this website that I sent here in the chat. That's very useful for me. I have no experience with HTML, but this was like could teach me how to do what needed to be done for the person that knew HTML.
Yeah, that's great.
I would like to just say that there are a lot of different tools for like build your website in an easy way, and so you get printed out, ready to go HTML code. And the problem is that that code will probably not work directly with the iGEM wiki.
Yeah.
So yeah, you want to, so you don't get that surprise close to the wiki freeze, that if you're using any kind of tool, and always try to test everything on your team page and see that everything works. And I hadn't heard of this WikiSync before, but I just looked it up a bit, and it looks very nice. And I think that's a really useful tool, especially if you're gonna integrate your other tools into the build.
That's great. Thank you. Wilmore, next question. Right. So version control. So the iGEM wiki itself, the iGEM servers or media wiki, I guess, has version control implemented into it already. How important is this? Should teams also have another system like GitHub on the side which is working for that, or does the iGEM wiki work out just fine? Does that work enough? Have you guys used anything else in your projects, or did you work with just the basic given version control?
We just used the iGEM wiki, the history there. I think it's enough for you to, if you're, it's enough for like, you can see the differences, you can follow, you can go back to changes, and it's good enough. But especially if you could combine with the WikiSync we talked about earlier, you can combine that with the Git. That would be, I think that would be extremely useful, but it's more technical. You need to learn Git, and if you don't know HTML, there's many different steps now you have to learn. And yeah.
Thank you. Do other speakers have anything to add?
So learning Git definitely helps, but right now I think WikiSync is actually the only tool that helps you interface Git with MediaWiki through CI/CD protocols.
Yeah.
But as someone on the creative production team, I can tell you that we're identifying that teams are finding it sort of harder and harder to work with MediaWiki, given that it's like 2021 right now. So yeah, there is a major shift that's happening with how wikis can be made easier by teams. So learning Git will definitely help in making wikis for 2022. As an insider, I can tell you that.
Right. That's great. So if you're done with this question, then we can move to the next one. Oh yeah, right. So this is also pretty technical. So when you try to upload, there are different pages or like different default CSS styles that iGEM itself gives us. Are there any other? So these are pretty obvious and like something that most teams would come across in their first try or like the first few weeks of trying out the wiki. Are there anything else that you think teams should keep in mind that you came across during your process, or like any other quirks of the iGEM wiki process that I think that other teams should keep in mind? That you remember? Anything important that teams should keep in mind?
I'd like to take this again. There is one very funny quirk that happens with MediaWiki. So if you're trying to upload a file, well, if you're trying to update a newer version of a file, that takes very long. So let's imagine you're in the dregs of your wiki editing process, and it's just before the wiki freeze, and you're trying to update a file that you had uploaded incorrectly. It takes time on the MediaWiki servers for that to sort of get updated, but you would be better off if you just uploaded the same file with a different name. That gets updated instantly, so that is certainly useful. And regarding leaving out some of the default CSS styles and some of the default quirks that come with a new page, it may be useful to go over this tutorial that high school US team created on YouTube. So they have like one template that actually takes care of resetting all the iGEM files, all the CSS, so that you get a clean slate when it comes to the iGEM wiki. Because by default, you only get to edit half a page if you don't reset some of the styles.
Yeah, that's something I think even WikiSync itself has and shares with their repository. So I think that's something that WikiSync also has. But yeah, thanks. Do the other speakers have anything to add, or should we move on?
I don't really remember any other quirks, but I do believe there were some. But yeah, these uploads and the CSS was definitely something I remember, and it was very hard. And I just want a tip is to try to learn like CSS specificity, the priority of which element. And also use the dev tool, the inspect page, where then you can see what style is affecting each element, and you can hopefully try to solve some of those problems.
Right, thank you. We want the next question. Right, Namaste. Is Namaste here? I think it shows.
Can you hear me?
Yeah.
Yeah, I think there was some issue. Okay. Yeah, so when teams run into issues, are there any other avenues where we could reach out other than the global Slack? It's always good to have a lot of forums to reach out to than just one specific thing, especially with just all of us who are, going through the same issues probably.
Yeah, I don't really know a specific channel or something, but feel free to reach out to other teams. This is a perfect opportunity to get some wiki collaborations. Reach out to a lot of teams and try to get some kind of collaboration going where you can help each other with the wikis. I think that is a perfect, if you run into these problems. And also you can proofread each other wikis. That's a perfect opportunity for these kind of things. And otherwise, I think that was Balder who linked the We3 School webpage. I think that's also a very useful tool.
I think we can move on to the next question if the other speakers have nothing to add. Yeah. Sorry. Right. So you already mentioned, Shiva already mentioned about how we should keep in mind the upload quirk nearing the wiki. So other than that, is there anything else that you guys faced during the wiki freeze that teams should keep in mind before they reach there? Like for example, should we not edit CSS files, something like that, or like Is there any other quirk that you remember from the wiki freeze portion of your time?
Yeah, as someone who made a lot of mistakes during the wiki editing process, I do remember just one more. So each of the pages that you edit are sort of cached. So suppose you make a change to a CSS template that you're calling within your HTML page. Make sure, and you save the CSS template, but you don't sort of save the HTML.
Okay.
What happens is that despite the CSS template being updated, it takes a while, somewhere between an hour to 2 hours for the updated CSS style to get called within your HTML. So this is just a MediaWiki quirk. Just make sure that if you finish editing a style or you make a change in your JavaScript, just make sure that wherever it is being called in your front end, the HTML part of it, just make sure to hit save on it once and make sure it works.
Right. Yeah, that's great. That's news. Pretty good advice. Thank you.
I recommend getting one.
Yeah, go on.
I recommend getting one of these. This is a D4, and you just roll it. Yeah, I got a 2. Your wiki freeze is now 2 days before the wiki freeze. You should be done by then. And then, like the 2 days you have left, that's just fixing spelling errors.
Right.
I think we did 1 week. I think that I don't quite remember. We took our wiki freeze 1 week before, did an all-nighter, treated it like a wiki freeze, and then we had a few days to look over our mistakes, and we weren't slowed down by the actual wiki freeze.
Yeah, I think that's a great tip, to try to make everything ready 1 week advance. I think that has always been our goal as well, but then you get those last results and you want to get them in on the wiki, so there will always be more results. So if the only way to be able to get them in on the wiki is to set the deadline much earlier, so that you will get to finish everything. And all the changes that you do in the last week, the servers will, or at least in my experience, the servers were much slower. So you need to take that in mind, that there will be longer times for you to upload the images or to make changes. So be more patient, and every changes that you do, try to test a lot more. Use different browsers, use different screen sizes and everything, and try to test all the pages and see that everything looks well, because if it doesn't look well now, you will not be able to change it later. So make more efforts to test everything.
Thank you.
Another
next question. Oh yeah, go on.
Sorry, Jason. I just have another.
No.
This is probably like a known practice, but try not to reference any new HTTPS links in your HTML, because the reason iGEM asks you to upload images to their servers is because it's easily callable. So anything that you reference through HTTPS makes it a lot slower for the iGEM servers to sort of pull in. So if you want to, say, include jQuery in your project, or just about any other framework you think would be useful, just always make sure that you upload it first to the iGEM servers and then sort of just call it from there as a template. Don't make any HTTPS requests.
Thank you.
So I think Shiva just partly answered a part of this question. So yeah, do you have any recommendations on the maximum file sizes? Or, like for example, you talked about how if we reference stuff, then it's probably going to slow the wiki down, or going to make it laggy. So do you have anything that we should keep in mind, so that we don't expect the user to have like a great high-end device or amazing internet?
I think one good practice may be to, like for example, in human practices pages or anything involving photography, you might end up uploading large files. I think the limit on iGEM is 2 MB, if I'm not wrong. So just try not to push it to that limit, because images take a lot of time to load on slow internet. So if just try and compress those images to like 300 KB or some such size, so that it loads faster without losing quality, of course.
Yeah, I think that very small images is the way to go. Really look at, like, you don't have to have an image larger than, yeah, I think that 300 kilobytes is a perfect limit to aim at. And of course, 1 or 2 images can be larger, and especially if it's kind of very much detail that you want to have, but don't push it with more than 1 image larger than that. And a small image don't have to be large at all. So just compress, and it doesn't have to be large.
And when you can use SVGs instead of JPEGs or PNGs, just go for them, because SVGs inherently probably don't take up too much space.
Right. So we're done with this question. We'll move to the next one. All right. So this is something that every team faces, I think. This is has been kind of answered by the reset CSS file that you were talking about. Is there anything else that you guys did? Like how? So you talked. I think Jonathan also talked about using the developer console to troubleshoot these styling issues. Are there any? So we've kind of already answered the question, but is there anything else that you guys would want to add or something? Is there anything else that you experienced while trying to troubleshoot this that you remember that you get? Or is that done? Are we done with this?
Just to repeat a bit, I think that, yeah, the dev tools are a great tool, and but another tool I want to mention is to use different browsers. Something that is an issue in one browser doesn't have to be an issue in another, or if it works in one, it doesn't have to work in another. So that's also a good way to see if is this a small problem, or is it a problem for everyone here? Or
yeah, cool.
Yeah, and the other thing teams might want to make use of is the screen simulations in Chrome or in any developer console, to try and look out for responsive designs, so that your text doesn't look too large. I think in general it's good to sort of not have text styles exceed the normal defaults, and it may also make sense to use the EM unit or the REM unit for
REM.
sizes for both text and images.
Thank you. Do you want the next question then?
Could you guys give us a little bit of insight on how these iGEM wikis are judged? So what might stand out as poorly designed, or what, based on what the rubrics might be for judging?
yeah, I think this is a very hard question, and if I know, and probably this is something I can get to know if I was a judge in the future, but right now I don't. But what I believe is that it is the content that is the most important. It's not important that you have the best technical web page, because we certainly did not have that, but I think that focus on your content, and I think that's the most important part.
I agree with Jonathan. I think the content matters more than fancy designs.
Yeah, there's no way really for us to answer this. But again, just keep it simple, stupid. just focus on what you have. And follow your, what's it called again? Judge form. And make sure you have everything.
Okay, great, thank you.
If I may add, I think the best thing you can do, if you, when you're thinking about this, when you think about the judges and everything, find somebody, your friend, your girlfriend, or whatever, somebody that doesn't know your project, preferably, and show them your wiki. And do they follow it? Like, do they have to ask you questions? And if they have to ask you personally questions, then you're doing it wrong. They should be able to get everything from the wiki.
I think that's a great tip. So reach out to others, and both iGEMers and non-iGEMers, because that's a very different crowd when you're working here. And I think so this is a good opportunity for collaborations, to read others, but also reach out to non-iGEMers, because then you get that is this understandable or not.
Makes sense. Thank you. I think this is one of the last questions. So
the last question.
Talk about your wiki, basically. Like, how was your wiki made? What was your inspiration for making a wiki?
Thing that you kept in mind when you went throughout, like what your philosophy was for building it?
We didn't really win an award for wiki, but we did get a nomination for best software. So I can testify that we looked at a lot of previous year wikis, such as the 2018 UPV Valencia Teams wiki, as well as 2016 Imperial College, and a few others from 2017 as well. So we just looked at a lot of the nominees and the winners, as well as some of the grand prize winning teams for inspiration. And we know one common theme we noticed was how easy the pages were to navigate. So with respect to most individual pages on iGEM wikis, we found that there is obviously a lot of text in it. So one neat trick that we thought was useful was to have a navigation bar for the section, for the headers within a page towards the side. That makes it easy for like judges to sort of click on the side nav to quickly access different headers in a page. So it makes the content more perusable.
That's great. Do the other speakers have anything to add for their parts, for their wikis?
One thing that we did when we were making our wikis is, like I've said most of this before, but we picked a few wikis that we liked, and then we decided what do we like about it, and then we picked a few wikis that we did not like, and we were like, why don't we like this? There was a lot of, remember, I'm not going to say any specific wikis, but there was a lot of wikis that was a continuous scroll, for example. You just scroll and scroll and scroll. I hated that. It made it very complicated to read. It made it very complicated to go back. It made it very complicated to go, like if I want to take a look at your lab results, it should not take me more than 10 seconds to find your lab results. So we implemented a stationary menu at the top of our wiki, so you could very easily go between it. And like I said before, I want to be able to show this to my mother, or your mother, or my father, or just my friend who doesn't have any experience in this. And I want them to be able to understand what's going on. But then I also want to show it to a prospective employer, to a judge. And I want there to be enough information there for them, to really dig into it. So you need to find the balance. between that?
That was a great answer. Remember the last question. Right. So we discussed, I think, most of the aspects of actual implementation of the wiki or writing the code for the wiki. So while designing your wiki, like making the layout of your wiki or how it looks like to the viewer, is there anything that you guys had in mind, or do you think the team should keep in mind, or has that everything been answered already, basically?
I think that a great starting point is to look at your team, who are going to work with the wiki, what are your experiences, what are your competences, what are you interested to learn, and from that work on how much time you have and see, do we want to build a new one? Do we want to use the standard page? I think the standard page is very underused, and I think that's something we really should use. And so see how much time do you have and start from there, and then also look. I think what Balder also said, that they took other teams' pages and looked at what they liked and didn't like. I think that's a perfect start to see how do we want to design our wiki.
I think most websites on the internet are actually some of the least text-heavy websites. Like the websites we consume on a daily basis don't really have as much text as an iGEM wiki. So it would make sense to try and look at frameworks or styles for documentation sites in particular. So things like Gitbook or Jupyter Books or any such documentation site could provide a better insight as to how you can better represent content in a wiki.
Right, that makes sense.
And yeah, I stand behind what I've said before. Just keep it simple. And then when you're done, then you can make it complicated.
I think we're done with the questions. So we'll move on to the discussion session. So if any of the teams have any questions, any of the attendees have any questions, then you can put them in the chat and we'll try to get the speakers to answer them.
I'm just going to probably plug in a sample guide that I made for a similar wiki workshop last year. So if people find this
That'd be
useful,
great.
let me know.
That'd be great. Yeah, thank you. So if the other attendees have no questions, and do the speakers have anything else to add that they wanted to say but hasn't been covered in these questions, then go ahead. Otherwise, I think we're done with this meet. Otherwise.
I would just say, yeah, just start now. Break it down into small, simple problems for you to solve. Don't try to write the whole wiki at once, and just have fun with it. Enjoy it.
Okay, I think otherwise. Oh, go on. Was someone keep talking?
Hey, if Jonathan and Shiva, if you guys have any general comments for all the teams, you guys can go on.
I think the important thing is to start early, as both my fellow speakers said. Really helps refine the final website that is going to be built.
And if you don't know HTML, start practicing yesterday. Otherwise, just good luck on your projects, guys. I hope you enjoy the competition. Hope it's a little bit more open than last year.
Yeah. So have fun at the 2021 competition. Good luck to all the teams.
Thanks a lot.
Thank you.
Thank you so much for
Thank you
attending.
guys for coming.
I think it was really helpful for everyone. We'll make sure to make notes for this meeting and send them out. We either put them up on our Instagram, or we'll send a link to everyone on the mails. So yeah, thanks a lot for coming, Jonathan, Shiva, and Padur. I think we can end this meeting and move on to the next part of our symposium.
Yeah, Jason, can you hear me?
Yeah.
Yeah. Thank you all the experts for your inputs. Since all the teams are extensively working on their wikis at this time, your opinion on wiki building and design was really beneficial for all of us. Thank you, Jason and Namaste, for introducing the speaker. We will now move on to our next event for the day. So our Cyanobacteria Symposium would have been completely incomplete without talking about advances in cyanobacteria research. Therefore, our next event is a talk by Dr. Selão, who will be talking about a newly discovered cyanobacteria strain. I request Isabella from team HKU Hong Kong to introduce Dr. Selão.
Oh, hi. I believe Dr. Selão is not present yet.
Thanks for informing Isabella. We'll wait for a few minutes until he joins. Hello. So, Dr. Salau's talk was scheduled from 2:20 GMT. It'll take him a while to join the meet. So, in meantime, you can consider this as a break for 30 minutes and get back again at 2:20 GMT, and then Isabella will be introducing him.
I did ask him to come 10 minutes earlier. So he should be here in about 5 minutes or less.
Perfect. Thank you so much. I think Dr. Selão is here. Isabel, can you please introduce him?
I am here. I'm just trying to figure out if my connection is good enough today, because yesterday we had some troubles and I would not like that to happen again.
Yes, we can hear you.
Okay.
Yeah, it's perfectly clear.
Okay, good. Yeah. So hello again. Is it my time already to start, or?
I will introduce you first to our participants today.
Right. Because I thought it was 3:20, so I was joining in quietly to wait for my turn, sort of.
All right. So good morning, good afternoon, and good evening, everyone. I'm Isabella from the University of Hong Kong. Our speaker today is Dr. Tiago Selão, who is currently a research fellow in biotechnology at the University of Nottingham, completed his PhD in biochemistry at Stockholm University, and was also a postdoc and senior research fellow for synthetic biology at the Nanyang Technological University, which was when he published the research he's going to present today. His main research focus is in using metabolic engineering and synthetic biology to develop sustainable bioproduction platforms for value-added molecules, specializing in photosynthetic microbes like cyanobacteria. Let's all give him a warm welcome.
You seem to know a lot about me. It's the joys of internet. Right, so let me just do share screen and this one, and put this in full screen. All right. Just get my laser pointer and we're ready to go. So I'm assuming that you can see this, but shout out if you cannot. So yeah, as you heard from Isabella, my name is Tiago Selão, and my focus is on cyanobacterial biotechnology. And today I'm going to talk to you about sort of the journey to isolate and characterize PCC 11901. We isolated in Singapore. And so this is published last year in Communications Biology. So if anybody has an interest to check details and so on, the paper is out there. So if you cannot find it, just let me know and I'll email you the link. All right, so I think for this crowd, I don't really have to work very hard at selling cyanobacteria, but nevertheless, cyanobacteria, of course, have interesting advantages as a biotechnology chassis. And one of them is that, of course, they use, rather than produce CO2, so their carbon footprint is negative in that sense. And they use light, which can be sunlight, as the energy source. And unlike plants, they don't require arable land, and they divide faster than microalgae and are in general easier to manipulate. And let me just minimize this here for a second. Yeah, so not everything's rosy. So you do have some issues, mainly for most cyanobacteria, biomass production is fairly low. Usually you work with just a couple of grams per liter of dry cell weight in bioreactors. And this also usually leads to low production titers, that and the issues of light penetration in the culture. So usually you will see when you look into articles on cyanobacterial bioproduction that the titers are usually under 1 gram per liter, which, unless you have a very expensive product, means that you are not going to be profitable. So in general, you can see in articles that the most commonly used strains are PCC 702, which is a marine strain. And then you have freshwater strains, such as the recently described UTEX 2973 by Professor Pakrasi's lab. 7942, which is sort of a classic, along with 6803, which was the first photosynthetic organism to be fully sequenced. So these are freshwater, and these two are sort of slower growing, and these two are sort of the faster growing. So we wanted to take all this into consideration and go into a bioprospecting adventure, if you will. So we wanted to find something that we could use as a cyanobacterial chassis, and we wanted to find it with characteristics that we thought would be ideal, namely that it should use seawater so that it would not contribute to water scarcity, because as you know, especially now with climate change, water scarcity is an issue that's going to become ever more prevalent. So if you can use seawater, this could be advantageous for biotechnology. Something that would have a fast growth for the obvious reasons, and something that would tolerate different kinds of stress. And I'm talking both heat as well as salt, and particularly important for cyanobacteria, high light, because if you put something in the sun and ensure you at midday, it's going to be over 2000 microeinstein. So it must be able to tolerate that, isn't it? And obviously we wanted something that we could easily transform and manipulate, because if it's very difficult to transform, then this becomes a hassle and people don't want to use it. And finally, we wanted to find something that would be highly productive, both in terms of biomass as well as production titer for some specific compounds. So at the time, as you heard, I was working in Singapore. I worked there for almost 10 years. And so we thought this would be ideal for this kind of bioprospecting. And so Singapore is in the equator, so it has constant sunlight hours, and the temperature doesn't deviate much from 30 degrees all year round. So this would make sort of an ideal situation for cyanobacteria, because if you have constant temperature at around 30 degrees, that's ideal for many strains. And then you know that you will have about a photoperiod of 12 hours every day. And of course, being an island, you have easy access to seawater. And then we thought that ideally we would want something that would be stress tolerant for salt, as I mentioned, and we wanted something that would take varying salt concentrations. There's a river here, the Johor River, and this is an estuary. So this would be ideal as a location because the salt concentration will fluctuate. So if you sample there, you might find something that is urea lime. And one of our collaborators is the owner of a fish farm, or was at the time. And we thought this would also be ideal testing ground because of the runoff from the fish farm would enrich locally for nitrogen and phosphorus, which would then allow us to have a higher local concentration of these nutrients to stimulate growth of photosynthetic organisms. And of course, they need good water mixing for the fish, so then this also helps in sampling. So then we went sampling. This is the first author in this paper, Artur Vodarczyk, and this is myself, as you can imagine. And so a step-by-step procedure. This is a classical isolation procedure. We took samples from the seawater around the fish farm in different locations. We took them to the lab, inoculated in the regular A+ growth medium, and then let it grow in 1% CO2 and in the light, constant light. And eventually we got some of them to grow green. And then we just repeated this step. We took some of this culture, diluted again back into the growth medium, and repeated this at least 3 times until we had something that was consistently growing quite strongly. And then once we had these cultures that were growing quite well, we then used some of them to dilute and plate, and we used varying dilutions, and we plated many plates. And of course, some of them are contaminated with fungus, some of them are overrun with other strains. You will have filamentous strains, which we were not so interested in for this particular purpose. Eventually, we got a plate, or several plates that had these colonies, which were growing quite fast. Then we picked them, restrict them, and they were also eventually growing fast in the restrict plates. So this is when we started to have a more or less pure monoculture of our strain. And of course, at this stage, we want to know what it is. So initially, you take it into a microscope, and we could see that the cells were slightly elongated. They formed short strands. But later, we realized that they are not multicellular at all. They form these strands while they're growing, but they're easily disrupted when you centrifuge or something. And so then we took this and we grew it again in the regular 87 medium without B12, and we could see that this grew with a lag in the beginning. And we thought perhaps, because we could also see on the plate some small tiny colonies still lurking around our green colonies, maybe this is still not completely pure. So then we thought, perhaps if we add vitamin B12, because many marine phytoplankton need vitamin B12, this will allow our cells to grow faster, overcome the contamination, and then we can pick the clean colonies and have a clean culture. And so it was, and this again demonstrated that the strain requires B12 for optimal growth. And using 16 sRNA, we identified this as belonging to the Synechococcus genus. And the small contaminants, we could also isolate those, and we isolated those in a mixture of 87 and LB. And this was from the Thalassococcus genus. And we think that this is probably in nature something that occurs quite often, that you will have a heterotroph that supplies, in this case, vitamin B12 as a cofactor in exchange for sugar, for example, or some fixed carbon compound. So it's a mutualistic relationship. So then we took them also to the electron microscope, and we could see that in TEM, we could see the thylakoid membranes. We could even see some that looked like a convergence zone for the thylakoids in the plasma membrane. But in this case, we could no longer see these strands that I mentioned. We could see them in the SEM because the processing for this is much milder, but this one requires several centrifugation steps, so then they are easily disrupted. So again, this proves that they are not multicellular. They just sort of aggregate together as they're growing, but this easily breaks. They have these hairy protrusions, as we call them. We think it's exopolysaccharides or pili. We are not quite sure, but they are definitely hairier than 702 or other strains. And they're about 1.5 to 3.5 micron long. We'll talk about the size later a bit. So we wanted to see, now that it was pure, how fast will it grow? And so first we had to find the optimal temperature, which was around 38 degrees. And the highest permissible temperature was 43 degrees. So it can tolerate quite a bit of high temperature. And at the highest light intensity that we could gather from the growth chamber, which is around 660 microns time, we got a division time of around 2.14, which is not too bad. In terms of salt tolerance, we could see that it could grow without salt. So it does not necessarily require salt. It will grow faster, a little bit faster, with 1.8 sodium chloride. And then it can tolerate all the way up to 10% sodium chloride, which is quite a fair bit. We were quite surprised at that. And then we put it head to head with other strains. And we wanted to see how it would fare if you compared it to 702 and UTEX 2973, which are like the ones in the same league, let's say, in terms of fast division times. And we could see that UTEX 2973 is still slightly faster, still sort of the champion in terms of doubling time, just under 2 hours. But 702 and what became known as 11901 were growing at about the same speed. And we could also see in terms of salt tolerance that it was a bit more tolerant than 702. You can see this is 7.5% sodium chloride. 702 is already struggling a bit, and this one is still going strong. Of course, UTEX is a freshwater strain, so it cannot tolerate that much. So long story short, we sequenced the whole genome, and then we compare using something called the average nucleotide identity. And so in this case, the closest relative was PCC 7117, and the average identity was around 97.5%, which is far enough to make this a new strain. So it has one circular chromosome, around 3 megabase pair, and it has 4 putative plasmids, which funnily enough, we could not actually circularize in the sequencing reaction. We assumed that they are circular, but we could not, some of them we could not actually close. The GC content's around 50%, and you will notice in the genome that there are several gaps here and here and there and there. And these regions are interesting because they actually have no similarity to cyanobacterial genes. So we are not sure where they come from. It's probably horizontal gene transfer from something else in the environment. And mostly it's glycosyl transferases. We are not sure what they do, but these are some of the major differences. We also found there's a gene that actually encodes for methionine synthase that does not need B12. So B12 is required for these cells to make methionine, the ones that do use this methionine synthase, MET-H, which requires B12. And then there's the MET-E gene, which does not require B12. And these cells actually have the gene, but it doesn't seem to work, or didn't seem to work until recently when we obtained some spontaneous mutants after a long selection process, which we are now characterizing. So it seems to be a fairly recent evolutionary change that can be reverted to a certain extent. So the next question is, okay, we have a new strain. Can we do something with it? Can we work with it? And so we made some constructs to transform, and we realized it was naturally transformable with linear DNA, can also use circular DNA. And we could transform it into the ACSA locus, from which you can use acrylate counter selection. This is the same as 702. Most antibiotics used for 702 work, although the concentrations can differ. We have noticed that it is more sensitive to, for example, streptomycin than 702. And so also mostly the promoters used in 702 work, and I would expect the ones used in other cyanos also work quite as well. So you have an inducible promoter here that works with IPTG, and several constitutive ones that we also tested in the meantime. So after this, there was a paper that came out about the same time from the Brian Flagger group in the US, which developed a new recipe for the growth medium for, in the case 702, a marine medium, which they call modified medium A, MMA. And this is based on theoretical assumptions, and this allows for the cells to grow to higher density. But when we tried to replicate that, we realized the medium actually precipitates quite extensively when you autoclave it. So we wanted to improve on that. And so we did a step-by-step optimization of individual components, mostly focusing on nitrogen, phosphorus, and iron, because we realized these were really the critical parameters. Everything else, trace elements and so on, they are really not critical to be increased for this. We realized that as we tested. And eventually we came to the point where we had something that we called modified 87, or MAD for short. And this are the concentrations that you can see. So you can see that it has slightly less nitrogen, certainly less iron, and a lot less phosphate. So with less, you can actually get the same or more than you would get with MMA. And so following on that, because we wanted to also see if we could optimize BG11 for the use of freshwater strains, because BG11 is also not optimized, we tried to follow a similar strategy by optimizing individual components. And this took a long time, but we realized that actually this is harder to do, because it seems like the balance between nitrogen, phosphorus, and iron is critical in BG11. So when you try to optimize just one of the parameters, eventually what happens is this, that the cells grow and then they crash very quickly. So eventually we realized that if you just multiply by 5 the recipe for the regular BG11 medium, that you get 5 times BG, what we call 5 times BG. And this actually works quite well, better than anything else that we tried. And this is about the same concentration as the MAD for nitrogen, phosphorus, and iron. And further additions actually didn't improve. It works worse if you try to add more nitrogen or iron or whatnot. So then we stuck with 5 times BG, and then we wanted to really test the limits of what you can get if you have optimized medium with all of these strains. So then we put them together at 30 degrees, 1% CO2, a light intensity that was fairly high. And then we had to ramp it up for 603 and 702. And we were surprised and slightly shocked to see that 11901 really could outgrow all of these and accumulate a lot of biomass. We were really not expecting this. And this was something that was particularly surprising considering that it's the same medium and the same amount of CO2, the same conditions for all of them. So this is something that is intrinsic to the strain. One thing that we noticed also was that the freshwater strains in general don't seem to be able to accumulate much more than 7 grams per dry weight per liter in optimized conditions. And this is something that we noticed. It's the same for 603, 7942, UTEX. They all seem to stop more or less at the same level. And that UTEX starts degrading phycobilisomes after roughly the 3rd day. You can see the color starts to shift away from this nice blue-green into the more greenish kind of hue. Sorry. Okay, so now that we have something that works well, can we still push it further? So we then focused on 702 and 11901 because they accumulate the most biomass. And we thought, can they still be nutrient limited? Because what happens if you say increase CO2? And interestingly enough, we went from, what was it, 15 or so to 21 grams per liter, and from around less than 10 to around 15 for 702. So there was an improvement. And here, the difference was less notorious between these two. And then one thing that we noticed was when we further doubled nitrogen, phosphate, and iron in MAT to create what we then called MAT2, then this big difference between them was again apparent. So then we went from 21 to 33 grams per dry weight per liter, and only an increase from 15 to 19 for 702. So one thing we noticed about all this is that 11901 seems to accumulate biomass at roughly about the same rate. It just stops earlier or later depending on the conditions. And PCC 702, on the other hand, seems to require more carbon input for the same nitrogen and phosphorus load to double the biomass accumulation. So this seems to point to differences in carbon fixation / allocation to the different parts of the metabolism. So, of course, at this stage, you're all asking, why is that? Why does 11901 behave differently if the conditions are the same? Well, the short answer to that is we are not sure yet. We're working on it. There are some hints. So one of the things is that we noticed that the cells get enlarged at high density because the OD and the biomass increase at some stage are not correlated to cell counts. And you can see in the FACS, the forward scatter, and also in microscopy images that the cells become larger than 702, and that they, the average, the distribution of them is definitely increased for 11901 at high density. And we're still working on this. There's many things that we don't know. But in the meantime, we thought, okay, since we have something that seems to be quite productive, can we make something with it? So then we use the proof of concept with this. It's just to make free fatty acids. So these are precursors for biofuels or specialty oils, or you can use the carbon chain to make specific lubricants, et cetera, et cetera. So this can be done by expressing a thioesterase, which will cleave off the fatty acids from the fatty acid synthetase, and at the same time disrupt the gene that makes it go back into the metabolism, the FAT-D gene. And this results in fatty acid excretion from the cells. This is already known, and then we to transform both 11901 and 702. And sure enough, then in 87, you can see production of free fatty acids in both, slightly more after 3 days in 11901. But then what was really markedly different was that in MAD and 1% CO2, this was 10 times higher, which was really surprising. And then after optimizing induction time and the extraction procedure and so on, we got like 1.5 grams per liter of free fatty acids. You can see how the culture looks. It's murky because there's so much, it just precipitates everywhere. It's a mess to measure. But it was so highly productive. And actually one thing we noticed is that the production increases 10-fold, biomass production only increases 1.5-fold. Again, we are not sure why this happens. And there's a lot that we don't know yet. So what triggers the cell morphology changes? What is the signal that makes the cells become enlarged? And does this mean that there are differences in terms of carbon fixation or assimilation or usage? And why does the fatty acid production increase so much in MAD versus 87? And can we do something about it if we understand this phenomenon? I mean, we think so. So this is something that, of course, it will need quite a lot of study to deal with. But for the moment, we have to keep digging because that's the way it goes. Somewhere we will find the answers. We don't know exactly when. So to finish off my talk, I would like to say that, okay, we have found an interesting strain, and bioprospecting is an exercise that sometimes can result in quite interesting discoveries. But also, I would like to point out that this doesn't mean that all the other strains are not good. That is not the point that I'm trying to make across here. So 11901 is a very interesting strain. It has these very interesting characteristics and many things that we still need to study. So it's a very interesting subject to study, which does not mean that all the others are now, made irrelevant. We don't need to think about them anymore. That's not the case, especially because, as was already shown using metabolomic studies in 702 and 7942 and so on, if you want to produce a particular compound, you will usually have to use a particular substrate, a specific node in the metabolism. And the metabolism for these strains is all different. You will have pools of pools of specific metabolites that could be important and that they are more elevated in one strain than in the other. So you really have to understand these strains deeply in order to take full advantage of them. Just because this one is highly productive for biomass doesn't mean that it will solve every problem that you can encounter. It is, however, a good chassis for green biotechnology, at least that's what we think. And one thing that I would also like to give you as a take-home message is that even though people use BG11 and 87 and all these classical media, that doesn't mean that the media are optimal and that this is where you should stop. In fact, this is a common strategy, if you use a heterotroph. So if you optimize growth conditions, you can eventually release a constraint in the metabolism that then allows your cells to be a lot more productive. And sometimes it can be something very simple, like in this case, the nitrogen compound, the nitrogen amounts seem to be quite important, as well as the phosphorus and iron. So yeah, grams per liter titers with cyanobacteria, yes, they are possible for some compounds. Again, it depends on what you're trying to make. It depends on how you engineer them. But as a proof of concept, it is possible to do this. However, to really be able to take advantage of all this, there's still much that we need to understand about the metabolic network, especially at high density. This is in a way, I'm going to say, a new frontier with cyanobacteria, because most studies use fairly low cell density because of light penetration. But what we can see here is that actually the cells can be productive at high density too. It's just that you need to work with them a little bit. So I think that this is more or less what I had to say. I realize it's a bit shorter than half an hour. But yeah, thank you very much. And now if you want to ask me any questions, please go ahead. I'm going to stop sharing for a second, maybe.
Thank you so much for your talk. I'd request all the team members to type in their questions if they have any questions to Dr. Selão about his presentation.
Chat. Oh, I have to stop sharing maybe. I hope I didn't have any glitches on my presentation today. Yesterday was kind of embarrassing.
No, it was absolutely clear today.
Yeah, I came to a different room today.
We'd really like to thank you for joining on both the days. It was very inspiring for us, and we felt really motivated by your presence on both the days. And even now, your clear description of methods and procedures is going to be really useful for our wet lab procedures of all the teams. And I really hope this strain brings with itself a revolution in cyanobacteria research.
Well, I don't know about revolutions. That's always I tend to under promise so I can over deliver, if you know what I mean. So one thing that is interesting in this is that it kind of shows the things that we don't know. You know, it more than just saying, well, it's very productive, that's amazing, etc. To me, the most interesting thing about it is that I don't know why it's this productive. I don't know why it does that, because if you just use a normal strain that you would use like 702, it doesn't do any of these things. Why is that? What's the trigger? What's the signal? What's the metabolic network that needs to be activated and so on? So to me, it's also sort of an interesting problem, you know, or like an interesting question.
So if there aren't any questions, we can move to the next event. Again, thank you so much, Dr. Selão, for joining us. We are really grateful that you could join for both the days. So for our next, thank you so much. So for our next event, I'd like to invite Thomas from Team Toulouse to come and introduce the games.
Okay, so hi everyone. For this event, this is more board game events. So we can have some board game online for to recover from this presentation. So we have the possibility to play Gartic Phone or Scribble, or Codename, as you want, for people who want to play. So what do you want to play?
Guys, if you can't unmute and speak, please type in the chat box.
Yes, it's an idea, Ashley. So I will create a room for the Gartic Phone, and you can connect to this room. So
So in meantime, as Thomas makes the room for Gartic Phone, I'd like to tell you that with this final event, we'll come to an end of day 2 of our symposium. I hope you all enjoyed these 2 days. We'd like to thank all our experts for taking time out of their schedules and being a part of the symposium. We'd also like to thank Asia ambassadors Avadhoot and Shrestha for providing us with the Zoom link. Thank you, Team Stony Brook HKU Hong Kong and Team Toulouse INSA-UPS for being the best organizing committee this event needed. And finally, thank you all of you present here for being a part of this 2-day Cyanobacteria Symposium. Without your efforts and presentation, this would not have been possible. Thank you for being an amazing audience and cheering all the participating teams. We'll conclude this event after this final game. Please check the chat. Thomas has sent the link for the.
I see that someone as me doesn't enter a nickname, so has a cool nickname. So everyone in the room know how to play Gartifon?
Thomas, it would be really great if you could give a short introduction for everyone.
Okay, so the Gartifon game. So we choose an ID and we write them, and someone has to draw our ID, and someone else would try to find the ID behind our draw, and so we transmit the ID and the draw one player to one player, and at the end of the game, we look at what was the original ID and what was the end of this ID. So does everyone who wants to play the Gartifon has joined the room?
Yes.
Okay, so maybe we can start. Yes, we can change. Okay, so so we must find your ID and write it. My gosh.
Oh, we're supposed to draw that sentence that appears, right?
Yeah, exactly. And you have a timer, so you must to draw quickly what you have to draw. So now we have all seen an ID or draw of someone. We will now reveal what we think about what we have to draw or to say what it is. That's a possibility.
Oh.
Okay, so yes, we have always the idea of the planet, so that's nice. So for Isa, nice meeting. Excellent. Nice love. That's right. Plate. Okay. So we have always the idea of many things on the pizza. So nice. So for Ash, picture. Temperature. Maybe I could nickname as a internet issue. Okay. So that was we kind of have another idea of the idea of. Okay. So for Vikram, I was speaking on a bed. Chilling on a bed.
Okay.
Yeah, we have always the idea of the bed, so that's nice. And, so for BD. Yes, that's nice too. So for cool nickname, one of the cool nickname. That's a Portuguese, so that's count as well. So for Ciano Daddy, I like the nickname. No idea what's this quick.
That's a little far from the initial sentence.
Okay. Rasmus. India. Oh my god. Sorry. Okay, so that was the last sentence. So do you want to make another party or another board game?
I'm down for either. How about everyone else? Why is everyone else muted?
Yes, I don't mind another round either. This was really fun.
I don't hear. Can you repeat, please?
There are 4 new players waiting for their turn. So we can have another round and they can play as well. They couldn't join the previous link because they joined late.
Is it possible to shorten the time we have for drawing? Perhaps that would be challenging,
Yeah.
but interesting.
Yes, we can do that. So maybe for new term, custom settings. Yeah. Maybe you can choose the limit option. There's a clock enable is measured custom. Okay. I can make fast. Okay, so I change one settings, so the time to draw and maybe to enter the 10 sentence. So we see what you to be. Does everyone has a sentence to write? So I guess I can start. Okay. So
yeah, sure.
yeah, that's what. Oh my god! If someone can find what I did.
That was quick.
This is too fast.
Oh no.
So baby dinosaur. Run for your life. Dinosaur. That's a cool superpower. Okay. Oh, next. Is that
Oh, I got this one.
Mafia? This is the coolest mafia I ever seen. Could they do cigarettes?
Can we download this one?
Okay, so Ash. Okay. So we have always the idea of simple. So that's good. Okay. So what's for Baidi? Explain the check. Okay. So we achieve a bit of the ID at the end. So next. We are all tired of Zoom.
Zoom fatigue.
Okay. So next. I was sure. Je play new sketch. Okay, that was fun. Krish. Okay.
Oh. Oh no. Okay. That's something that we really achieve. If it isn't modified, why not? Well.
I could see food.
Oh.
Okay. The next touch. Sunset of Paris. Okay, so that's it. So we want to continue to play, or do we do make another game? Is it the end of the symposium?
I think we should conclude our symposium now.
Okay.
Thank you so much for the game. This was really fun. Again, thank you so much all for joining the symposium. We had a lot of fun in these 2 days. Thank you so much for joining. And yes, please stay tuned for our future events. Thank you.
Yes, a huge thank you to the team of IISER-Pune who mostly managed the entire symposium. Thank you so much.
Yeah, that's right. Thank you, IISER-Pune, for organizing this event. Thank you.
All right, bye-bye. Thank you.
Bye.
Bro. Okay, let's leave. I hope you shouldn't have started my class. This is getting wrecked.